Now after discussion of blast furnace chemical reaction, now important question arises in the mind. How can we relate thermodynamics with this, and most important application of Allingham diagram? So let's discuss. Now we know that the basic reaction for the reduction part, that is nothing but FeO. When we are adding coke, that gives Fe, either solid or liquid part, depends on the temperature of furnace, changes to CO, that is carbon monoxide. Here main two thermodynamic reaction we should consider. FeO solid converted to Fe solid and half O2 gaseous, means transformation of FeO to Fe. So delta G change for FeO to Fe change. And second, carbon solid plus half O2 gives CO gaseous. So here delta G change for C to CO. Now, when we have value of these two reaction, if overall value of this reaction is more and more negative, we can say reaction is maximum spontaneous as per thermodynamic feasibility. Now, let us apply the Allingham diagram versus delta G and the T. Now, if you observe in Allingham diagram with the reference diagram part, now the slope of Fe to FeO change, that is in upward direction, and slope of C to CO change, that is in downward direction. And we have discussed where these two are intersect, delta G 0, and below temperature reaction is more feasible. So in this case, when you observe that value nearly below 1073 Kelvin, it is best reducing agent for reduction of oxide. Now similarly, in the same way, we can utilize the case of Allingham diagram, and we can say carbon monoxide is better reducing agent even at lower temperature for reduction of Fe2O3 or Fe3O4. So this is thermodynamics and Allingham aspect related to blast furnace. Now at the end of blast furnace, some points for applicative as well as MCQ point of view. Now the iron obtained from the blast furnace contains, most important highlight, about 4% of carbon and many impurities in smaller amount such as sulfur, phosphorus, silicon and manganese. This is known as highlight, pig iron, and cast into different type of shapes. Cast iron is different from pig iron, and it is made by melting pig iron with most important scrap of iron and coke using hot air blast. It has slightly lower carbon content, about 3%, and is extremely hard and brittle. Now for the reduction, most important for objective, 1 mark. Wrought iron or malleable iron is the purest form of commercial iron, and it is prepared from cast iron by oxidizing impurities in a reverberatory furnace lined with most important hematite. So now we know that Fe2O3, that is known as, now if you remember, ferric oxide, that is nothing but hematite, and Fe3O4, that is known as magnetite. So for objective you can highlight hematite, so inner linings are coated with hematite, Fe2O3. This hematite oxidized carbon to carbon monoxide, so Fe2O3 plus 3 carbon, that gives 2Fe plus 3CO. Limestone is added as a flux. So what is flux? So we are adding such a substance which is used in larger amount and which is helpful for the removal of unwanted impurities which is available with ores. And sulfur, silicon and phosphorus are oxidized and passed into the slag. The metal is removed and freed from the slag by passing through rollers. So this is the entire topic related to blast furnace, thermodynamic and Allingham diagram related discussion and uses and its further application. So now in next session we'll discuss about extraction related to copper metal.